Hello, good day everyone. Today we are going to talk about graphing the trigonometric function, and I am Idris Abdelkader. Before we start, at the end of the class, students are expected to know the properties of sine and cosine graph. So let's begin. Amplitude. We say that amplitude is the maximum or minimum vertical distance between the graph and the x-axis. And we say that amplitude is always positive. Amplitude is the height of the graph from the middle to the top. The distance from the middle to the top is the same as the distance from the middle to the bottom. Now, let's talk about period. We say the period, the number of degree or radians we must graph before it begins again. That's what we call the period. But here we can also say that the period of the function is the length along the x-axis from the beginning of a cycle to the beginning of the next cycle, just as you can see. Now, the sine function, imagine a particle on the unit cycle starting at 1 to 0 and rotating counterclockwise around the origin. Every position of the particle corresponds with an angle theta, where y equals to sine theta. As the parts move through 4 quadrants, we get 4 pieces of sine graph. Now we say that from 0 degree to 90 degree, the y-coordinate increase from 0 to 1. From 90 degree to 180 degree, the y-coordinate decrease from 1 to 0. And also from 180 degree to 270 degree, the y-coordinate decrease from 0 to minus 1. From 270 to 360, it increased from minus 1 to 0. Now we can see, as you can see, theta, when theta equals to 0, sine theta will also be 0. When theta equals to pi all over 2, which is 90, sine theta, sine 90 will be 1. When theta equals to 180, which is 5, sine pi will be 0. And also for 3 pi all over 2 minus 1, pi 2 pi will be 0. Now graph of this sine function. To sketch the graph of y equals to sine x, first locate the key point. These are the maximum point, the minimum point, and the intercept. Now they ask us to locate the key point. The maximum point, we have our x value and we have our sine x value. Here 1 is our maximum point, 0 is our intercept, and the minus 1 is our minimum point. Look at it in the graph. It starts from 0 because sine 0 equals to sine 0 equals to 0. So as sine phi equals to 1, no, 5 over 2 equals to 1, and that's how it moves from 0 to 1 to minus 1, then to 0 again. The cosine function. Imagine the particle of the unit cycle starting at 1 to 0 and rotating counterclockwise around the origin. Every position of the particle corresponds with an angle theta, where x equals to cos theta as the particle moves through the 4 quadrants. We get 4 pieces of the cos graph. Then from 0 degree to 90 degree, the x coordinate for the sine, it is y coordinate. The x coordinate decrease from 1 to 0. From 90 degree to 180, the x coordinate decrease from 0 to minus 1. When it is from 180 to 270, it increase from minus 1 to 0. And when it is 270 degree to 360 degree, it increase from 0 to 1, just as illustrated with a graph below. Graph of cosine function. To sketch a graph of y equals to cos x, first locate the key point. These are the maximum point, just as we did for the sine function. The maximum point, the minimum point, and the intercept. We have our value for x, then cos x. Also we have the value, and our maximum point here will be our 1. Our minimum point here will be -1, and our intercept will be 0. We also have it in a graph. It is being illustrated using a graph. It starts from 1, just as it is on the table, starting from 1, then move to 0, then to -1, then to 0 again, then to 2 pi, which is 1. And now let's take a look at an example of sine graph. Before that, there is something we need to take note of. Given a sine b x, then our a is our amplitude, while our period will be 2 pi divided by b. 2 pi divided by b. When we want to find our amplitude period, the number before x divided by 2 pi. 2 pi divided by the number before x. Then example, we are given 5 equals to y equals to 5 sine 2x. Now our amplitude will be 5, then our period will be 2 pi divided by 2, because 2 is the number before x. Then we will have pi. Then we have our graph now. Then let's graph it out. Here our amplitude will be 5, because 5 is the amplitude. The height of our graph will reach 5. It will stop at 5, because 5 is our amplitude, so the height will stop there. Then, and our period will stop at pi, which is 180. That is, you can see it here, pi. Then half of pi is 5/2. Then quarter of pi will be 5/4. Then 3/4 of pi will be 3 pi/4. Now let's sketch the graph. You can see how exactly it will look like. Then let's look at another example. Sketch the graph of y equals to cos x on the interval -5 to 4 pi. Partition the interval 0 to 2 pi into 4 equal parts. Find the 5 key points. Now we are supposed to find the 5 key points. Graph one cycle, then repeat the cycle over the interval. Now let's see how we're going to do it. Our 5 key points are the 3, 0, -3, 0, 3. And our 3 is the maximum, and 0 is the x-intercept, and the -3 is the minimum. Now let's graph it. These points you are seeing are our 5 key points. Is the value for y equals to 3 cos x. These are the values. They are our 5 key points that we are looking for. Now let's sketch the graph. You can see 3 is under 0. 3, and our maximum, it starts from 3. So our graph will start. We are going to start sketching our graph from 3, then down to 0, then down to -3, then to 0, then to 3 again. Let's take a look at. Yes, we have the graph, and this is the graph of y equals to 3 cos x. Now, in summary, the domain is the set of real numbers. The range is set of y values such that -1 is less than or equals to y less than or equals to 1. The maximum value is 1, and the minimum value is -1. The graph is a smooth curve. Each function cycles through all the values of the range over an x interval of 2 pi. Then with the last one, the cycle repeats itself identically in both directions of the x-axis. Now we have our assignment for you. The question goes like this: sketch the graph of y equals to 2 cos half x, 2 cos 1/2x. Submit your answers and any inquiries to gmo smith at